So today we're going to introduce the quadratic formula. Now, this is an incredibly important formula because it's going to break down a really big aspect of what we normally hand factor for, and it's going to allow us to find the roots of any quadratic, regardless of whether or not it can be hand factored. And it's based off of the idea of something called the vertex and the discriminant. And now, without getting into too complex of an analysis, the idea behind any quadratic is if I have a quadratic and I have my, let's say, drawn like that on the axis, what I know is that from my vertex, we know that this thing is symmetrical on the left side versus the right side. So if I can find that central point on the x-axis, I know that the distance over here is the same as the distance over here. Now my drawing might not be exactly, but I know that this distance is the same thing as that distance. So if I find this point and I know this distance, I can add it and subtract it from my vertex and get root 1 and root 2. So without, like I said, getting into too much of a description, too much of a lesson of that distance on a quadratic is going to be what we call the discriminant. And we find that by using b squared minus 4ac. So the quadratic formula is built off of saying, okay, I'm going to take that vertex, negative b, or 2a, and I'm going to add and subtract, add the distance to root 1, subtract the distance to root 2, but I know it's going to be the same thing both times, and I'm going to use this, the discriminant, which is going to be b squared minus 4ac. And again, let's not get too caught up in how we created that, but the idea is that we find the vertex, add the distance, and take the distance back away. Boom, we'll have each root value. So today, all of our quadratics are going to hand factor. So you could actually hand factor each one of these, but we're not going to because I want a chance to practice this where it works out nice and neat. Not all the time will it work out nice and neat, but it's a good way to introduce this topic so you can check your work when you're done. So let's go ahead and use the formula. I'm going to take x equals negative b over 2a, and I'm going to both add and subtract the discriminant. So the b squared minus 4ac. All I need to know is my a, my b, and my c. So my a is my number out front, my b is the number in front of the single x, and my c is the number without an x. So let's go ahead and plug that into the formula and see how we do. Cool. So my a here is 1. So 4 times a over 2a. My b is 8, so negative 8, 8 squared. My c is 16. And so 98% of the quadratic formula is not necessarily understanding how to create this. It's an arithmetic process to simplify what you see right here. Nothing crazier. We've got our two roots. I'm going to start simplifying it. So that's a negative 8 plus and minus 8 squared is 64. 4 times 1 is 4. 4 times 16 is negative 64. All over 2. I know 64 minus 64 is going to be 0. Perfect. And so at this point, what we're going to do is I am going to split. I'm going to split it into an x equals a negative 8 plus 0 over 2, and x equals negative 8 minus 0 all over 2. And I'm going to solve each one of these. Negative 8 plus 0 is just negative 8 over 2, which is negative 4. Negative 8 minus 0 is negative 8 over 2, which is negative 4 again. Awesome. So we notice that the discriminant here is a 0, so that must mean that my vertex has no distance between the roots, and the only way that we would get that, let's just use this line for example. Let's say this is the line of the vertex. If my vertex was right here and it curved, I would have a positive discriminant. The only way I can get that gap to be so tight is if my two roots are on the vertex. So I'm going to see something that looks like that. Get rid of that right there. I'm going to see something that's so close that the two roots are on top of each other. Now again, you can't actually prove this by hand factoring. We're not going to worry too much about it. The idea is that, boom, we take the vertex and we add and subtract that distance, and we'll get the two roots. So what we've got right here, I need to find my A, which again is 1. I need to find my B, which here is 3, my C, which is negative 10. And I'm going to plug it into the formula of vertex plus or minus the discriminant. Plug in our values. Let's see, negative b, which is 3, b squared minus 4 times a times c, all over 2a. And so again, most of the quadratic formula is not some complex process, it's just simplifying what you've got right here. And so this is arithmetic, and we're really confident in our skills with arithmetic. So that's a negative 4 times 10 is a positive 40. Okay, so at this point I have x equals negative 3 plus or minus the square root of 49 all over 2. And so I'm not quite at the point where I'm going to split yet because I haven't fully simplified my graph. I'm going to come over here and say, okay, x equals negative 3. I know the square root of 49 is 7. Now I'm going to split. So x equals negative 3 plus 7 all over 2. I'm getting that root. And I'm going to get x equals negative 3 minus 7 all over 2. So then I'm going to subtract the distance. So I'm going to add the distance and subtract the distance and get my two roots. That's 4 over 2. There's my first root. Over here I got negative 10 over 2, which is negative 5. Perfect. There we go. So knowing what we know, what we're going to do is I'm going to identify the A, the B, and the C. And I'm going to give you the formula, and what I want you to do is I want you to give this a shot. Pause the video and resume it when you're done and see how well you did. There we go. So pause the video. There's the formula. There's your A, your B, and your C. Plug those in and see how well you do. Let's see how we did. So in this case, I have a negative 15. I have a negative 15 squared, negative 1, negative 50, negative 1. And so here's our first catch. What a lot of you probably did was you said, okay, if I need a negative b, my b's already negative, you probably just plugged in a negative 15. But be careful, because I want a negative whatever b is. So if b's negative, I want a negative, which makes that a positive. The second thing that you probably did, if you weren't paying attention, was negative 15 squared. What many of you probably did was you squared 15 and you said 225, and then you made it negative. Remember, most of the mistakes in quadratic formulas are not in the process, it's in simplifying what you've got. Negative 15 times negative 15 is positive 225. And lastly, again with negative signs, negative 4 times negative 1 is positive 4, times negative 50 is negative 200, all over negative 2. Cool. So then I'm going to take that and I'm going to say, okay, x is 15 plus or minus the square root of 25. And that's going to give me 15 plus or minus 5 all over 2. And at this point, I'm going to go ahead and I'm going to split. I'm going to find the distance to the right by adding it. I'm going to find the distance to the left by subtracting it. There we go. So how'd you do? Let's try it. Let's just give this a shot. These are both just further examples. Nothing crazy, just making sure our arithmetic is good. So let's go ahead and plug this in. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, my a is no longer just a 1 or a negative, it's actually a number in and of itself. Not that 1 wasn't a number in and of itself, it's just a bigger number. There we go. 13 is 4 times a times c all over 2a. There we go. So I get negative 13 plus or minus 169. Let's see. That's going to give me, well, 2 times 15 is 30. Times 4 is 120. Cool. And so at this point, I'm going to split. So I get x equals negative 13 plus 7, so I can get that distance to the right. I get x equals negative 13 minus 7, so I can get that distance to the left. Boom. There we go. And so if you follow that same logic on number 9, let's go ahead and knock number 9 out real quick as well. Like I said, all we're doing right here is we're just practicing plugging in our values, practicing the arithmetic involved in reducing this. Again, I notice that I'm taking a negative of a negative, which is going to end up making that a positive. So I get a positive 16 plus or minus, let's see that, I think that's 256. Okay, so 3 times 21 is 63. That's a positive 63. 4 times 60 is 240. 4 times 3 is 12. 240 and 12 make 252. Okay, I keep going. And I can actually reduce this. That's going to give me an x equals 8 plus or minus 1, negative 3. And then in this case, now that I've fully reduced everything I can, now I'm going to split. So x equals 8 plus 1 over negative 3. And x equals 8 minus 1. It's the distance to the right and the distance to the left. There we go. Compare that to see how you did. And that's it.